how can we detect paint lines? So let's display our points using intensity color. All classes will be on. So we can see what kind of density values are available. So we have them displayed in the main TerraScan window. If you go to fields, you can activate or deactivate intensity values. So this will be now the last column because all others are switched off. So now I have in the last column my intensity value. However, my intensity values are not corrected. So they are quite noisy in this data set. Higher intensity is closer to the scanner. And I will now just display a hard surface class, all off. And also I will display asphalt class. So because we will not need other classes for detection of paint lines, the significant amount of points is in asphalt and in hard surface class, which will be used further on for paint lines classification. There is a possibility to check intensity histogram. From main TerraScan windows, if we go to tools, we have here add-on and option to view histogram. So we have in this laser intensity histogram window a possibility to select just the, for example, hard surface class. And then we can have a look on the intensity values using laser 1, or we can switch and use just the laser 2. If we have a look on the values here and the distribution, we can conclude where the largest change is happening. So if the values are higher, so over 20 and something thousand, we can choose as a threshold and use the upper part of this intensity distribution curve in order to classify brighter points, which will be potential points for paint line detection. Intensity values from sensor to sensors are different. There is also a strategy to normalize intensity values before starting using them, but as I said, depends from scanner to scanner and distribution from which value of minimum to which maximum value intensity value goes. And this is the nice way histogram to view it and to have impression what is your average, median, and spread. So in next step, I'm going to create a macro to adjust the intensity values for the scanners. So to look at this intensity scale. And in general, find paint lines action finds linear change of a given width from points. So the linear chains may represent paint lines in the center, so those ones, but also we can detect the ones which are on the side. I will switch off now surface of the road which is displayed in background so we can see better our, yes, we can see better our intensity values on the road. There is a possibility also to erase display of the surface, but that's an alternative. I'm going back to TerraScan. As you can see, we have those paint lines along the center of the road, but we have also paint lines on the side of the road. So today aim is to detect all of them. So let's have a look how we can do that. Our macro should first classify points with high intensity values. For that, we will use by intensity routine in TerraScan. And from hard surface and from asphalt surface class, we are going to classify bright points in a separate class. So the darker points we will exclude. There is also possibility to classify paint lines using by color routine, because paint lines could be also yellow, right? Not only white. Depends on this marking and type of the road, city road or highways, whatever. And this could be used as an alternative classification beside bright points. If there is some noise, so depending on the quality of your sensor, we can exclude this noise in the surrounding of paint lines in order to get really linear vectors and continuous vectors. So polygons which are showing the asphalt area of the road maybe are useful now in order to exclude points outside the area of interest, and therefore we will use the edge of pavement because it's available for the purpose of this demo. So let's show you how to classify potential points inside polygon of the pavement edge and how to use them further. I'm going now to create in Tools a macro. I have already prepared Find Paint Lines macro. Here it is. So the first step in the macro, it is to apply correction. So we have to correct our intensity values. And for this correction, we will use TerraMatch. In TerraMatch, there is a possibility to save corrections and reuse it later on in a macro. So if you go to TerraMatch, there is a tool, Find Intensity Correction. And in Find Intensity Corrections, minimum range will go from 2 meters to 50 meters. Then the range interval is 20 centimeters. Sample radius just 10. centimeters, and for the classes we will just use asphalt and hard surface class. Just these two classes, as I explained before, are useful for further detection. And it's important to follow a direction of trajectory. This is automatically navigated over here, so it's the right trajectory folder. And then press OK. So it's going to compute now intensity correction. And we can save that file for intensity correction as TMS file, and then reuse it in our macro procedure. In this case, macro is just like design algorithm, which helps to achieve this automatic extraction. It takes some minutes. If there are some questions now, it's a good moment to ask. So please feel free to type them in chat. Okay, intensity correction result is available for scanner 1 and also for scanner 2. So now we can save this correction. We will not use smoothing, but if there is some noise or outliers to be excluded, some smoothing can be performed. So I can use this intensity correction to save over it. And now when I am applying macro step, I should invite exactly that TMS file as a first step. Then second step of our macro is to classify points by polygon. For this, we will use the pavement polygon on the level 23. That's the level over here. I can display it. So it's the white one. I have selected it now, so now it's a pink one, so it's more visible. So within this polygon, from class asphalt and from class hard surface, from this classes, we will classify points to model key points. So in this case, model key points are temporal class. So basically like transition to next steps and press OK. Then in the next step, we will classify points from model key points class to terrain ground. And terrain ground will be our final class from where we will really extract the paint lines. And we will just use bright points. So the threshold here, which I have decided to set up, is over 24,000 up to maximum. So this is like 16-bit of the colors, which could be the values, which could be the maximum and expressed. So terrain ground will be final class with points to be used for paint line extraction. I will show it later on how the result appears in that class. Then in the next step, I will thin points using action thin points by adjusting density of the surrounding points in X and Y horizontal direction and also in vertical direction. This is for the purpose to reduce some points, and also the noise in intensity values can be reduced by smoothing points, not only by thinning points, but since we have here a density of up to 4,000 points per square meter, this is fine to do it. We will show the step in a few minutes. And the ones which are not going to continue, they will go to temporal class model key points, which do not pass for the further use of extraction of paint lines. And the ones which we will use further on, they will be in this terrain ground class. So we are just moving the ones which are not good. And finally, search for paint lines in class 9 terrain ground will happen by using find paint lines routine, where we are already using the width of paint lines. This is some standard 12 centimeters value. We can measure it just to be sure. So I will like try from here to here. So here it's even more. I will try it in this single line. So 13 centimeter. But yes, you can ask the road engineers what is the standard. The value which we have is 12, 11 here. It's varying, but let's use 12 as default saying over here. We can choose terrain ground class as a bright class, and we can do this along selected vectors, all find all lines, output file will be as a text file. So the action writes the extracted paint line information into text file where the information includes the center point coordinates of a paint line, reliability value also, then a normal direction in X and Y, and extension of the line. So beside importing this into design file of MicroStation, you can import it in any other CAD software or in GIS software. I will run it on this block, but we can move it later on and demonstrate also on some another block. For the purpose of this macro execution, I will select the central line because that's required, and I will run it on loaded points. So here I can, for example, save report or just close it. But it's good to save because then you can include it in project reporting. So now I have points classified in different classes, such as model key points and terrain ground. So we can view now those classes, like if we exclude, let's view now the points which are in terrain ground class. So as you can see in terrain ground class, we don't have just the paint points on the paint line markings, but we also have some other points which pass this criteria of using bright intensity values. But that's not a problem. Their distribution is not linear and it's not continuous, so they won't pass this algorithm to find paint line, because here we have also the width threshold and the logic of having linear distribution of the points and having this linear chain. Then we can also check what is remaining in this model key points class, what is remaining in hard surface, just surrounding points, and in the asphalt class. Basically all points are now in model key points class and terrain ground. I will turn on all of the classes which were included in this macro. And let's now check where our paint lines are written. And txt file where we have the coordinates, elevation, then we have the values, which is showing the reliability, normal direction in X and Y, and extension of the line. Now we can import this by going to Tools and Read Paint Lines. And this txt file we can import by setting minimum length. If we want to exclude some line detection shorter than 1,5 meter, we can do it now. Some requirement for minimum paint line length, which we have as information, is this value. That's why we are using it. And now our paint lines are imported as green vectors. You can, of course, change the this color in some another color, but I have imported it in triangulated surface level. So I will go undo and change to paint lines level 5. I can see it now over here, and import it in paint lines level 5. And now I will switch other lines so that you can see clearly the success of this detection. Points thickness is enlarged, but let's use now the value 1 so that you can see better highlighted detected paint lines. So we have here well detected paint lines in the center of the road and on the edge of the road. They can be now used also as road edge in the area where there is they're not continuous. They are also very well detected. And our advice is to check them manually, and if you need some improvements, you can use quite many of those MicroStation tools for manipulation with lines.